So energy, the continuing supply of energy is a fascinating area. It's obviously, there's a lot of interest in this, but there's a whole range of different timescales over which future energy supplies are going to evolve. And there's a range of constraints on which energy is going to be the dominant source at a given time. So at the moment, if you look at the mix of energy supply, over 80% or so is derived from hydrocarbons. Now obviously that leads to a lot of carbon dioxide emissions or carbon emissions by burning those fuels. And there's a lot of research and interest, as we know, in terms of weaning ourselves off those energy sources and moving into renewable energy sources, or perhaps needing nuclear fuel as an energy source. And there's a timescale over which those transitions can occur. So the use of wind power or solar power over decadal timescales can become more and more important, but we can't suddenly switch from one power source to another. There's enormous investment in the infrastructure. So for the next few decades, it's very likely that we're going to still have or still be using a lot of fossil fuels. And so that brings in, I think, two big challenges. And the first challenge is, can we capture the CO2 emissions from those fossil fuels and sequester them underground? And I think geosequestration of CO2 is a very interesting technology, but it's really disposal of that CO2 to stop it adding to the atmospheric CO2 levels. So, and there's a number of challenges there, but actually building up a big industry that would dispose of CO2 and put it into depleted oil and gas fields or deep saline aquifers in itself is a very big enterprise that would need to be set up. And there's a lot of work going on at the moment in the technical challenges of doing that. And I think we have a good understanding of some of the issues controlling the viability and practicality of geosequestration of CO2. I think the other big challenge with continuing source or supply of fossil fuels is actually continuing to recover the extremely large volumes of oil and gas that are produced today. And as reservoirs become depleted, or the nature of reservoirs become more complex, we need to have more understanding about the detailed flow paths through the reservoirs, and there's going to be increasing use of different technologies, polymer flooding and other technologies, to actually try and improve the recovery factors or the amount of the oil that we can actually recover from these systems. And there's some very simple physical processes that make it very difficult to do that, such as the fact that fluids always want to travel down the path of least resistance, and once you sweep those zones, it's then trying to sweep other zones of the system. So that's a big challenge where there's a lot of interesting and exciting fluid mechanics to be carried out.